Today here on the bench a Kenwood TM732. So as you already can see, it is a dual band VHF and UHF radio, and this radio came in because it failed during transmission. So suddenly and unexpected there was no output power any longer, and well, even afterwards, after releasing the PTT, there was no transmit power anymore. So, well, yeah, we have to check what has happened to the radio, and well, this problem is only on the 70 centimeter band, so on UHF. It is not on VHF, as I have been told by the owner. And well, so we do our checks when we get a radio in. So that means we have to verify if the finding what we can discover here is exactly the same what the owner has told me. And then if we know everything is exactly what I've been told, then we can start troubleshooting. So therefore I have already connected the radio to the signal generator, and I adjusted the signal generator exactly to 426.850, and I set the level of the signal generator to minus 93 dBm, because on VHF and UHF minus 93 dBm represents S9. So that is a bit different to shortwave radios. We know that on shortwave radios S9 is already reached with a signal level of minus 73 dBm, but on ultra shortwave radio like this here, S9 is represented with minus 93 dBm, so that is a very much lower level than on shortwave. And what you already can see here is that our S meter for 70 centimeter is showing a signal strength of S9. So this is what we expect, and now I want to switch on the deviation, and we will see if we receive our test tone. So that is now okay. So what we can hear is our 1 kilohertz test tone, and now I'm feeding in a deviation of 2 kilohertz and an audio tone of 1 kilohertz, and as you can hear, so I can increase it a little bit, but yeah, you can hear that the receiver is able to receive this signal and is able to give it back in the speaker. So the receiver section is obviously working on UHF. Well, and now I have switched over to the 2-meter band. So the signal generator is set to 145 megahertz, and yeah, you can already see that the little receiver here is able to catch this signal. And well, what you can see here is that it is it 5 or 10 over 9 with the same signal level. So we are still feeding minus 93 dBm. So that means that obviously our signal meter has a wrong setting. So it should show exactly S9. So this might be this is needs to be re-alleged. So that is what we have to do later. But for the moment in time, we can say okay, both units, so the 2-meter unit and as well the 70 centimeter unit is working on receive. So let's once again switch over to 70 centimeter, which is 426.850. And now I'm switching over. So you see now we receive on 70 centimeter, and you see here is the setting very good. So we really have S9 here on the meter. I do it a little, I set it a little lower. So we see, yeah, that is working very well. And well, after we know that both receivers are working, we will check what will happening on transmit. Okay, for transmitter test, let's start with the 70 centimeter band, which has been reported as faulty, and I have set the transmitter to low power, which can be changed by this little push button. So you can change between high power, mid power and low power. So low power should be something around 5 watt. High power is yeah, something around 35 up to 40, and mid should be something around 10. So yeah, well, let's start with low power. Well, and therefore I thought it is good to show the display of the radio tester. Yeah, I'm switching off our receiving tone, and yeah, as I said, it is on 70 centimeter. I've set it to low power. Let's start with low power and see what is gonna happening. Okay, have a look. So you can see in the right upper display that the radio is reporting 5.4 watt output power on UHF, and well, so this is a little bit different to what the owner has told me. So he said the radio failed on UHF, but now we have power. Okay, let me switch it to mid power, and okay, so we have 12 watt on mid power, which seems to be okay as well. And now let's switch to high power, and yeah, 31 watt, so that should be okay. So that seems to be a final stage which can produce 30 watt. And yeah, so 70 centimeters, so UHF is working on transmit and on receive, so no problem at all. And well, yeah, you can read on the left hand down display the deviation, and yeah, it is reporting 4.5 kilohertz, so everything seems to be okay on 70 centimeter. So let's change now to 2 meter. So that is very easy. Now the PTT is switched to 2 meter, and we are expecting a signal on 145 megahertz. And yeah, let's see what we gonna have there. Okay, so therefore I'm going back to our displays, and I switch here on low power, and yeah, I'm pressing already the PTT, but well, nothing happens. So let me increase the power to maximum, what it is right now, and you see nothing is happening. Also, that is what you should see down here. So watch the upper display. So when I'm now pressing the PTT, you clearly see that that you see an upcoming indication for on air. So the radio is reporting that it is on air, but it isn't. So there is no output signal so far. But what we can see when we watch our amp meter, so so that is 600 milliamps in receive, and when I now press the PTT, you see now we have 1 amp as drone power. So that is what the radio is consuming for the moment in time. So that clearly means that something is happening inside. So the radio should show any transmitter power, but it doesn't. So yeah, once again I will show you the display, and I'm pressing and releasing currently the PTT several times, but the radio tester stays on receiver test, so the generator is working, but well, there is obviously no incoming signal into the radio tester, and yeah, that clearly tells us that there is something wrong with the 2-meter transmitter, and therefore it is the opposite round. So the owner told me there is something wrong on UHF, but our finding is that there is something wrong on 2-meter. And well, one side discussion here is that it is always good to prove what the owner has reported to you. Just imagine that we would have already been started to perform fault-finding troubleshooting on the UHF unit. You know, that would lead us, I don't know, somewhere where we definitely do not want to go. So it is really always good to do a first check when the radio comes in, and yeah, you see that we have a fault on the 2-meter band, and that means now our next steps are definitely different from the steps we would have been gone if there would have been really a problem on the UHF device. So okay, let's start with our next step. Let's open the radio and let's watch the VHF unit, and let's see if we can find any obvious sign of some fault on the on the VHF unit. So maybe some burn marks or whatever. So that will be next step. Yeah, okay, so our unit is open, and here we have our VHF device, and yeah, you can see the signal generator is also set to the 2-meter band, and we can hear our test tone on 145/900. Okay, let's switch it off. So receiver is working, and yeah, as we already know, no transmit. Also we can see the sign in the display. So well, we have now to investigate what's going on, and yeah, therefore let us have a look inside. And well, you know, here we have signs that somebody must have been in before, and as well here on this yeah, it must be a connector on the other side of the board. So somebody seems to re-soldered this connector, but beside that I do not really see any mark that somebody has been in before. So everything seems to be Okay. Well, no, nothing, nothing to complain so far. Everything seems to be okay. Well, good. So then we need to start checking some voltages. So for the final, so this here is the final, and the IC10, which is this hybrid unit, is the driver. So next will be to check if signal and voltages available at well, the important points. So okay, let's do some measurements. So I want to probe if our amplifier, so the final, is getting its supply voltage, and the second test what I want to do is if he get its switching voltage when we press PTT. So therefore, yeah, I have tried to put the meter in place so that you hopefully can read the display. And yeah, okay, so on this point we should have our supply voltage, which is available, as you might see. And on this point we should have our switching voltage. So when I when I now press PTT, okay, so let's try. Yeah, okay, so when I press PTT, you see that the meter is reporting our 12 volt. So switching volt is also available. So releasing the PTT, it is switching off. And once again, yeah, when I press PTT, our switching voltage is available. So we know that the switching circuit inside is working. So there is no problem. Now we have to check if we get our drive, and the drive voltage, so that is our VHF frequency already. And well, as yeah, you remember, we are on 145/900, so that is our frequency, which we also expect at the input of our final, and the input is pin 1. So let's check if we find our drive. Okay, so now we can watch the screen, and I will connect my probe to pin 1 of the input of the final, and yeah, let's see what we have. Now I'm gonna press the PTT, and yeah, what you can see is really we have a drive at pin 1, and it is 1 volt RMS, yeah, which you can read down here. So have a look down there. So that is 1 volt drive at pin 1. So what we can say right now is that the complete circuit seems to be okay, but we definitely have no output. And yeah, so that brings it down to the point where I expect we have a problem with the final stage. So yeah, let's check what we can see here. Yeah, and to prove that something is wrong with the final, I'm now at the output pin of our final stage, and yeah, I'm pressing PTT. So you see there is a reaction on the screen. So yeah, the unit seems to try to go into transmit, but yeah, so there is definitely no output power. Yeah, we definitely have a problem with our final stage. So I hope that we can do something on that, because otherwise the radio needs replacement on the final stage, and that makes it a bit expensive. So yeah, you can see right here. So here we have our output, and I've probed the output, and yeah, we see that there was no reaction on the scope, so no signal available. And again here, this is pin 1. So this is the input from our driver. So the driver is this hybrid unit here, and at the input we clearly had a nice signal, which leads to the assumption that something is wrong with our final stage. Okay. Well, here in the radio again, the well-known Toshiba SEV17. Yeah, so this unit is known for getting faulty. So yeah, let's try to get the cover off, and let's see if we can do yeah, something to get it back to life. Okay, so this is the open hybrid final stage, and well, you know, this final stage is known for having some problems with the solder joints. So because if the final is getting hot, so all the solder which is on, let me go a little bit closer, so you may see here all the different traces. And well, you know, these traces are known for getting interruptions, yeah, mainly due to the excessive heat which are getting on this unit under operation. So that is known, and well, I think it is really difficult to see on the camera, but now I'm too close. Let's see now. It is not it is not possible. But down here we have definitely an interruption. So what I'm gonna try, so it is exactly here, but I'm not able to get close enough to show it. Yeah, it is, I guess it is not possible to see it on the camera. But anyway, so what I'm gonna try right now is heat up the solder iron and try to rework this trace and see if then we will have power again. Well, now you definitely can see where I have been with the solder iron. You know, that is normal because it is here on a ceramic plate, and that means it is absolutely difficult to get this part of the trace under temperature, because this ceramic together with the metal and yeah, the heat sink itself, which is the whole chassis, is really a very good heat sink. And even when you crank up your temperature on your solder iron, it is really difficult to heat it up. So you definitely see where I tried to rework this trace. But you know, if it works, then it will be fine. So now I do not see any interruption any longer, and therefore let's check if it works. So it is set to medium power, which means radio should transmit with 10 watt. And well, yeah, let's see if it works. So now we are still on receive, and now I push the PTT. Hey, and look at this. Is this nice? So the radio is producing output power again. So that has been the problem. So yeah, so we had definitely an interruption here on this trace, and now the amplifier seems to work again. I mean, you know, maybe this is only interims, because you do not really know what has happened to the complete hybrid. But this, you know, is good to check. If it works, fine. So then you can use your old final stage for another period of time. And if it doesn't work, so if it will fail again after a short period, well, then, you know, okay, we have to change the final stage. But for now, it is working, and that is great. So let's switch to low. So this is low, and there we should get 5 watt. So let's check. Yeah, 5 watt output power. so that is good as well. And yeah, let's switch it to high power. Now it is on high power, and let's check what we have. Is this a kind of beauty? It is 42 watt. That is really great. This is really great. So that means yeah, radio is working again. Everything is good. So yeah, I put it back together, and then it can go back to the owner, and hopefully this repair works for a long period of time. But if not, then yeah, we know we have to change the final stage, and then the radio is good again. So therefore, well, it is nice to get it to this point, and I know in 80% of all known cases this repair works for really a long time. So that's it. That is the end of the repair. I think I do not need to show you when I put back the housing and so on. So that is the repair, and if you like it, please give a big thumb up. And if you do not have subscribed to my channel, just do it right now. Please subscribe, and thank you very much, and catch you next time. Bye.